Alright, so in this video we're going to learn how to graph a linear inequality. Now that's very similar to graphing a line in slope-intercept form. We're going to use the same method for graphing a line in slope-intercept form. So if you're not familiar with that, please see my video on graphing a line in slope-intercept form because it's very similar, okay? The only added piece is that we have an inequality symbol. Alright, so up here, the lines are a little different. So if you have less than or equal to or greater than or equal to, so if you have that little line underneath your inequality symbol, it's going to be a solid line. If you just have less than or greater than without the line underneath, it's going to be a dashed line, because that means that none of the solutions on that line are included because it's not equal to. Whereas it would be a solid line because all of the solutions on that line would be included in your solution. Okay, so that is one difference. And also with linear inequalities, we shade one side of the graph. All right, so if it's less than or equal to, you're going to shade below the line. If it is greater than or equal to, above the line. So basically less than, below, we shade. Greater than, above is what we shade. All right, so let's try this first problem right here. We have y is less than negative 2x plus 5. So let's go ahead and just graph it using slope-intercept form. So this is my y-intercept, that 5, and then negative 2 is my slope. So plotting 5 on my y-axis, 1, 2, 3, 4, 5. My slope is negative 2. So I'm going to use negative 2 over 1 because I need a 1 underneath for my run. So I'm going to go down 2 and to the right 1, down 2 and to the right 1, down 2 and to the right 1. All right. And then to get some other points on the left-hand side of my graph, I'm going to use that negative for my run. So I will go up 2 and back 1, because remember, with every fraction, if the fraction is negative, the whole fraction is negative. And you can apply it to either the numerator or the denominator. So to get some points on the left-hand side of my graph, I'm going to apply the negative to my run. So I'm going to go up 2, 1, 2, back 1, up 2, back 1. All right. And so it's just less than. So it's not less than or equal, it is just less than. And so I'm going to have a dashed line. And I have a dashed line because none of the solutions or none of the points on this graph are solutions to this linear inequality. All right. And then I need to shade. So since we read this as y is less than negative 2x plus 5, I'm going to shade below the line. So this is below the line, and not quite shading, but basically these are all solutions to this system, not this system, solution to this linear inequality. If you're not quite familiar or sure about shading above or below, that is okay. Just choose a test ordered pair or a test point. So I'm going to choose the ordered pair 0, 0. That's my favorite one because it's easy to plug in. If I choose the ordered pair 0, 0, I'm saying that 0, 0 would be a solution to this linear inequality because it is on the side that I shaded. All right. So the ordered pair 0, 0. If I plug it in, it should give me a true statement for x and y. So if I plug in 0 for y and x, I get 0 equals negative 2 times 0. I'm plugging in 0 for both because I'm choosing that test point. And simplifying that, negative 2 times 0 is just 0. And I get 0 is less than 5. That is, in fact, a true statement. And so that tells me that I shaded the correct side of the graph. So after you shade, if you're not quite sure, choose an ordered pair on the side that you shaded. Or even if you choose one on the other side. I like to choose the point 0, 0. So if you would have shaded the other side and you chose the point 0, 0, well, you would not have gotten a true statement. All right, so just to recap, we're graphing a linear inequality. Solid line, if you have an equal to underneath. Dashed line with no line underneath. So in this case, we did not have a line underneath. And if it's less than, we shade below the line. Greater than, shade above the line. All right. And so all of these solutions on this side, or all of these ordered pairs on this side of the graph, are solutions to this linear inequality. But not included are the ordered pairs on the line, because we read that as y is less than negative 2x plus 5. So none of these points on the line are included on the graph. All right. So we've graphed this linear inequality. All right, so we have another problem here, a linear inequality, but it is not in slope-intercept form. So I need to rewrite this inequality in slope-intercept form. And remember, slope-intercept form is y equals mx plus b. And in this case, we want an inequality in the middle. So it would be greater than or less than or equal to. But I want my y by itself basically on one side. All right. So if you're not familiar with how to solve for a variable, please see my video solving 1- and 2-step literal equations. It will really help you with what we're going to do right here. Okay. But what I want to do, I want to isolate the y. So I want to add or subtract and then divide. So right here I have a negative x. So since that is a negative x, to move it to the other side, I want to add x. I bring down the 2y, bring down the greater than or equal to sign. But now I want to write the term with my x first because I want my slope first. And remember, the term with the x, or the number in front of x, is your slope, all right, which is your coefficient. So that would be x plus 6 because I have a positive 6. So I wrote my x first. Now I still haven't isolated my y, so that's 2 times y. So I want to divide both sides by 2. And I'm left with y is greater than or equal to. Well, if we don't see a number in front of our variable, what is it understood to be? A 1, right? So this is an understood 1, so I can rewrite this as 1/2 x, and 6 divided by 2 is 3. All right. And so we've solved for y. We've written it in slope-intercept form. 1/2 is my slope, and 3 is my y-intercept. All right, so I'm going to plot 3 and use my slope to get other points on my line. So 1, 2, 3. My slope is 1/2. Rise over run, so up 1 over 2, up 1 over 2, up 1 over 2. And I'm going to just keep going. All right. But I want some points on the left-hand side of my y-intercept. So since that's a positive 1 over 2, I can rewrite that as negative 1 over negative 2, because that would reduce to negative 1 over, that would reduce to positive 1 over 2. So that negative over negative, I could go down 1 and left 2. Down 1 and left 2. I'm using a double negative to get points on the same line. All right. And so we have our points, or our ordered pairs. And we notice here that this has an equal to sign underneath. And so since that has a line underneath, it is going to be a solid line, meaning that every point on this graph, or on this line, is a solution. It is included, and I'm kind of drawing over it. All right, and there we go. Now, we're not done, because remember, with linear inequalities, you have more than one solution, so we have to shade one side of the graph. This says y is greater than or equal to, so I'm going to shade above the line. Greater than or equal to, or just greater than, either one, we shade above the line. So this is my shading. So all of these ordered pairs on this side of the graph are solutions. Also included are the points on the line. All right. Again, let's choose a test point just to make sure. Let's see. Test point. Again, I'm going to choose the test point 0, 0. Okay. And if I choose the test point 0, 0, let's plug it in. So if I choose the test point 0, 0, that means I should get a false statement because 0, 0 would not be a solution. So if I plug in 0, 1/2 times 0 plus 3. And we get 0 is greater than or equal to 3. And 0 is not greater than or equal to 3. That is a false statement. So 0, 0 is not a solution. So that means I shaded the correct side of the graph. So we have graphed this linear inequality. Okay, so for our last problem, we have x minus 2y is less than 6. Looks very similar to the problem we just did, but it's a little different, okay? And we're going to see why. So the first thing we want to do is solve for y to rewrite this inequality in slope-intercept form. So subtracting x, I'm left with negative 2y is less than negative x plus 6. I'm going to divide by a negative 2. Now remember, if you're solving inequalities, so if you were solving just a regular equation without graphing, what would you do if you divide by a negative, if you remember? Remember that we flip the sign when we divide both sides by a negative. So in this case, since we're dividing both sides by a negative 2, instead of less than, we're going to flip this symbol to greater than. And again, that is because we're dividing by a negative number. All right. So please remember that. Otherwise, you're going to shade the wrong side of your graph. All right. I'm left with negative x over negative 2. Remember, there's an understood 1. So negative over negative reduces to positive 1/2 x. 6 divided by negative 2 is negative 3. All right, so always double check your work, right? Subtract x divided by negative 2, flip the sign. So instead of less than, it is greater than now. So now I'm going to graph this inequality. Negative 3 is my y-intercept. Since this just is greater than, that would be a dashed line because we don't have that equal to sign underneath. So dashed line, there we go. And now, since this is, ouch, y is greater than 1/2 x, I'm going to shade above my graph. All right. Now let's choose a test point. My favorite test point again is 0, 0. All right. Easiest one to plug in. And so if we plug in 0, 0, we should get a true statement because we're saying that 0, 0 is above my line, which I shaded. So we're saying that that is a solution. So let's check it. 0 is greater than 1/2 times 0. So I'm left with 0 is greater than negative 3. And yes, that is a true statement. 0 is in fact greater than negative 3. So I've shaded correctly. Now let's take it a step further. What if we were asked to find some points that are a solution and that are not a solution? So any point on this graph would be a solution. So if I chose the ordered pair 1, 1, that would be a solution. If you plug it in, you should get a true statement. If I chose this point, that would be a solution. So any point on that side would be a solution. But now let's look at this point here. This is the ordered pair 0, negative 3. All right. If we plug that in with would that be a solution? And hopefully you already know that because it is a dashed line, but just to show you, this is x, this is y. So negative 3 is greater than 1/2 times 0 minus 3. 1/2 times 0 is just 0. I'm left with negative 3 is greater than negative 3. That is not a true statement. Negative 3 is equal to negative 3. So that is a false statement. And so that ordered pair 0, 3 would not be a solution, even though it is on the line. And we know that because it's also a dashed line. So no ordered pairs are solutions to this system, not this system, but this inequality that is on the line. All right, so we've solved this linear inequality by graphing. We've gotten our solutions, and hopefully you're comfortable with graphing linear inequalities.